Let's do this problem from your lab assignment, section 11.10. They want us to find the sum of the series. This looks awfully convoluted here, but if we see a couple of patterns arising, that would be good. So there's a 3 to the 2n, pi to the 2n. This is 2n factorial and a negative 1. So I think that is kind of leading me to look at this cosine function with a 2n factorial in the denominator, x to the 2n power, and an alternating negative 1 to the nth power. So cosine function is what we're going to use. Now what we want to do is we want to match up all the terms that have 2n, because that's what the x is going to end up being. So we have a negative 1 to the n. That's going to be here. That's the alternating series part. We have x to the 2n divided by 2n factorial. So the only thing that we need to worry about are pi and 3. Pi in the numerator to the 2n, 3 in the denominator to the 2n. So I think that's what we have, pi over 3. So what we're saying is that this series is really the cosine function evaluated at whatever x value this is. Well, that's just pi over 3. And what is the cosine of pi over 3? Along the unit circle, the cosine of 0 is 1. The cosine of pi over 6 is 1/2. The cosine of pi over 4 is root 2 over 2. And the cosine of pi over 3, I believe, is the square root of 3 over 2. And then the cosine of pi over 2 is 1. So that's it. I guess that's not it. I think I was looking at the sine functions. So the cosine starts with 1, and then it goes pi root 3 over 2, and then root 2 over 2, and then it goes to 1/2. Sorry about that. Okay. Hope that helps.